these are some symbols of electrical components used in a PV system. So the most common symbol you'll see drawn by me and by any PV engineer would be the solar PV module or panel. So we'll call that PV panel. The next most common component, particularly with grid-connected systems, is an inverter, something that converts DC to AC, and so that's the symbol for DC, and that's the symbol for AC. And so this is an inverter. And the third most common component is a battery. And the sort of electronics symbol for the battery is, that's one cell, that's many cells, that's the end of the battery bank. And so that would be a battery, this being the positive, this being the negative, or the anode and cathode. And so this is a battery. But it's a bit overly technical, that symbol, so frankly I'm quite happy drawing a battery as basically what looks like a car battery. So either of those I would consider to be the symbol for a battery. Then you'll find symbols for switches. That's a switch. There's subsets of switches, which is specifying their characteristics. So you'll get switches that are also overcurrent protection devices, like this. So we'll call that overcurrent. And a switch, so it does both things. I think in common language that would be a circuit breaker, CB for short. And you also get what we call fuse switches, which is a fuse and a switch in one. So we'll call that a fuse switch. More technically, it's called a fuse switch disconnector. Love those really overly complicated terms, but that's what it is. And that's what you'll often find as the main isolator in a battery system. So let's put these together and draw a PV system. So the PV system consists of a module, well, usually many modules, so for shorthand, ... So that's known as a string of modules, which are then connected to some form of isolation device. Where that is depends on what you're doing, and that's connected to the input to an inverter. There's an inverter, converts DC to AC, and if this inverter has the functionality of battery storage, you would also see a battery drawn somewhere in the diagram. And so we've got a battery like this, and you may well draw what we call the loads or the load center as an output. So I could do that very simply and just say an active and a neutral. So that's our 230 volt output, AC. And on the input side, we'll have a positive and a negative, which is DC, which is from the PV array. And the battery will have a certain voltage, and I'll often write that on there, indicating the voltage of the battery bank. So there's a fairly simple diagram of a battery storage inverter that also has inputs for PV.